Hello everyone, welcome to the next video. In this video, we are going to discuss the topic epicycloid. What is this epicycloid is all about? Epicycloid is the curve generated by a point on the circumference of a circle which rolls without slipping along another circle outside. We are calling it as epicycloid. Rolling circle and directing circle. Radiuses are very important. Take down this question. Draw an epicycloid curve generated by a point on the circumference of a circle of 30 mm radius rolling without slipping. Rolling circle radius is equal to 30 mm. Directing circle radius is 100 mm. How to calculate the included angle? Theta is equal to small r by capital R into 360. It is equal to 30 by 100 into 360. It is 108 degrees. So with this included angle 108 degrees and using AutoCAD software, how we are going to construct the epicycloid, we'll see. Once the AutoCAD software is opened, please check the initial settings once. Units, precision 0, OK, limits 0, 0, 420, 297, Z enter, A enter. Whatever the initial settings we have learned, those settings has to be kept. Dimension style, modify, symbols and arrows, arrow size 3, text height 5, primary units 0, OK, set current, close. Next one is format, point style. Click on the appropriate point style, point size 3, OK. Now it's time to calculate the included angle. Included angle we have already calculated. I think theta is equal to small r by capital R into 360. That is equal to 108 degrees centigrade. 108 degrees. So make sure that ortho is on. From here, the point of 100, that is the rolling circle radius, directing circle radius. From here, rolling circle radius is 30. From the end point, we are drawing a circle of 30. Okay. Now, by using line command, this is my starting point. Use the command length 130 less than included angle from here to here 108 degrees. 108 degrees means total included angle. It has to from if we calculate L less than theta, I am giving it as 360 minus 108 is equal to 342. Okay. Please check the calculations once. Then measure it before going to further steps. From here to here, the included angle is 108. Okay. Dimension, aligned dimensions from here to here, 130, right? I'm deleting that one. Circle 30. Okay. Directing circle radius is 100. Trim the unwanted portions, TR double enter. Okay. This is the curvature, right? Draw the center line also. TR double enter. Divide this center line into equal number of parts such that these equal number of parts must be equal to the number of divisions what we have performed on the rolling circle also. Divide. By using divide the circle into 12 or 8 parts. It's up to you. 8 parts. So now divide the center line. For my convenience, I am converting that center line to yellow color. Divide this center line into how many parts? 8 parts. And name them by using the text. Similarly what we have done in the cycloid video. This is my point, starting point, height 3, rotation angle 0, P 1, 2, 3, 4, 5, 6, 7. And these are my centers, C1, C2, C3, C4, C5, C6, C7, last one is my C8. Okay. Now, after writing all those things again, using the circle command, from here to this center point to 1, make a projection. It will intersect, this first line will intersect the point 7 locus. Similarly, from this circle to 2, it will intersect the 6th line. Remember one thing, 2, 6 is different from center line. It is not the case in cycloid. Both are same. Center line and 2, 6 lines are same. Next, third line, it will intersect the 3, 5 line will be the locus lines lie on the same circle. And the 4th point. To maintain cleanness, I am trimming all those things, unwanted portions. Trim. Okay. Now, what we have to do? From each locus line, locus C1 centers, draw the rolling circle radius. This is my rolling circle now. So, rolling circle radius of 30. Where it intersects the first line, mark it with using point, modify toolbar. I already made the regular practice. I am converting this locus line to red color. Previously for cycloid also I have done the same thing. Now move this circle from C1 to C2. Hold the center point and move to C2. From here, take the point from there where it intersects the second locus line. This is the second locus line now. Carefully mark it one and convert that color to red. Just to avoid the confusion. Okay. From C2 to C3. From C2 to C3. Draw point, single point. This is my third point. I am converting that color to red. Similarly, from C3 to C4. It's the midpoint, center point. Half of the revolution is over. That indicates. Okay. So mark that point. Later on, convert that point to red color. From C4 to next one, C5. Right? C5. This is my 5th point. Draw point, single point. C5. Mark this one also. Thereafter, from C5 to C6, draw point, single point. C6 line, where is the C6 line? That is this one. Carefully mark the low point on the locus lines only. Otherwise, the curve may be of irregular shape from C6 to C7. C7. So mark that point also very carefully. This is my point. I am converting to red color. And the last point is the end point, right? I am converting to red color. Okay. Later on, delete these rolling circles to avoid the confusion. To keep it also, it's no problem. What we will do is we will extend this line so that after trimming there will be no confusion. Now join these locus lines carefully by using a spline. Carefully drag on that curve. Three times, enter. Escape. This is the epicycloidal curve what we got. Later on, click on that curve. Convert the curve to some appropriate color. Increase the line weight. Make sure that line weight is on. Okay. Points on the curve is very important. Text. This is my P1. This is my P2. P3. P4. P5. P6. P7 and P8. P8. Now again use the command text, write the text epicycloid. In this way we will generate the epicycloidal curve. In the next video we are going to discuss hypocycloid. Thank you.